Hey guys, it's me again. Here is the first math video, like I said. So I'm planning to teach anything ranging from grade 10 math, according to BC Canada standards, all the way to ordinary differential equations, which is a higher university math type of course. And the way I'm going to do it is I'm not going to necessarily teach the whole curriculum again, because as I stated in my last video, you can find that on Khan Academy or Patrick JMT and such. But I'll just give you problems and I'll apply the concepts to my fullest extent. But anyways, here is our first linear algebra problem. Z equals I plus 1 to the power of 4. And now our goal is to try to find the value of this and separate it into its real and imaginary components. So let's begin. We're going to use polar coordinates to solve this, but the first thing I'm going to try to do is a traditional way. So 1 plus I to the power of 4, I solved this when I was really lazy and had nothing to do in my life. It equals I to the power of 4 plus 4I cubed plus 6I squared plus 4I plus 1. And it actually equals, let's see, that's 1. This cancels out with this. 1 minus 6 plus 1 equals -4. Now, I was lucky here because it's only to the power of 4, but what if this was like to the power of 20 or 100? Then we can't use this method, can we? So we're going to use polar coordinates. Now, generally, an imaginary number, z, can be broken down into its real and imaginary parts. A plus B, I, where A is real and B is imaginary. And you can actually even draw this on a graph like this. Sorry for the sloppy lines. The markers don't really work well here. 0, and think of it like an X and Y axis, except this is the A part and this is the B part. Now, let's just focus, and then you could have this like this line here where this is A and this is B, and this is the point A and BI. The Z is generally also equal to R E I theta. And according to Euler's theorem, e to the power of I theta is equal to cos theta plus I sine theta. This is Euler's theorem. And now theta is obviously like, with A and B that I just drew, you can make a triangle out of it. This would be A, and this would be B. And then, this would obviously be R. You could solve it with Pythagorean theorem and theta. So that's the concept we're going to be using here to solve this problem and find the real value. So let's focus a bit on 1 plus I. Forget to the power of 4 for a second. So we have this. A and B and 0. Now, a plus b, 1 plus I, so a would be 1, and b would also equal to 1. Now, on a separately, we could draw the triangle for this off the grid. A is 1 and b is 1. And b is 1. And with Pythagorean theorem, we know that r is root 2. Now this theta is pi over 4. Theta is pi over 4. Okay, so r e I theta. So z is equal to 1 plus I. Well, not necessarily z, I'm sorry. 1 plus I, which is equal to root 2 e to the power of e to the power of I pi over 4. Sorry for the way I drew the e, but you get the idea. And let's just multiply this to the power of 4. Z, okay, so root 2 to the power of 4 is, root to the power of 4 is just 4. And then e to the power, e times all this to the power of 4 would just be e to the power of I pi, which is equal to 4 cos pi plus I sine pi. This is 0. And that's -1. 4 times -1 is -4. And now we are done this question.